All right, so this is good. We just concluded with number 5. So let's look at video number 6, which deals more with systems. You do have these 2 problems here that you want to look into and complete. But for right now, let's go ahead and start looking to solving systems with elimination. So using elimination, you want to add vertically after eliminating a variable. So looking at 78, for example, if I added negative 2x plus 2x, they eliminate one another, allowing me to solve for y. So I'm going to go ahead and start with number 78. And I'm going to go ahead and add vertically, knowing that these are my inverses. So I'm going to go ahead and add a negative 2x plus 2x. They cancel out. And I'm left with 3y minus 6y, which is a negative 3y. And then 7 minus 16 is a negative 9. Now I'm going to go ahead and divide both sides by a negative 3 to get a y value of negative 9 divided by a negative 3 is a positive 3. So now that I know what my y is, which is a positive 3, I'm going to go solve for x by plugging it in either to the top equation or the bottom. It doesn't matter. I see that the 2 is positive, so I'm going to go ahead and plug it into the bottom, but it doesn't matter which one. I'm sorry, I'm plugging in for y, so I'm going to plug it into the top rather. So it's a negative 2 times x plus 3 times y, which equals 7. So now I'm solving for x after I plug in a 3, y equals 3. So I get a negative 2x, 3 times 3 is a positive 9 equals 7. Now we're going to go ahead and subtract 9 from both sides. And you get negative 2x equals a negative 2. Divide both sides by a negative 2 to get x equals, so a negative 2 divided by a negative 2 is a positive 1. So now I know that when y is 3, x is a positive 1, and this is your solution over here. All right, so that's systems of equations via elimination. So let's go ahead and take a look at number 80. Number 80, if I add, I'm not going to eliminate either variables. So what I'm going to go ahead and do is, since I see that they have the same terms as both 9s, if I make one a positive, then I can eliminate those. So I'm going to do that by multiplying the top by a negative 1. So by distributing a negative 1 to every term in the parentheses, it changes the signs to the opposite. So I'm going to go a negative 6x now, a positive 9y now, and then 9 times a negative 1 is a negative 9. So now I can just add vertically. So 8x minus 6x, 8x minus 6x is a positive 2x. Now these are inverses of one another. Since they have opposite signs, they cancel out. Now 27 minus 9 is 18. And last but not least, all I have to do is divide both sides by 2. So x equals 9. So now that I know that x is equal to 9, I can go ahead and plug into either other equation to solve for y. So I'm going to go ahead and plug into the top equation right here. So for x, so it's going to be 6 times x minus 9y equals 9. So we said x equals 9. So 6 times 9 is 54 minus 9y, which is 9. Now I'm going to go ahead and subtract 54 on both sides. Bring down the negative 9y, which equals 9 minus 54 is 45, negative 45. All right, so I'm going to now go ahead and divide both sides by negative 9, and y equals a positive 5. So the solution to this system is going to be when x is 9, y is a positive 5. All right, now let's go ahead and look at the next example, number 82. All right, so now if I add right away to eliminate, I'm not going to eliminate a variable because I'd get 2x here and negative 2y here. I'd still have x and y, but I need to eliminate one of them to be able to solve for the other. So what I'm going to do is I'm going to eliminate the y's and solve for x. This way I could distribute up top and rewrite it below, and it's just a little bit easier. So the opposite of a negative 3y would be a positive 3y. So I need to get a 3 up here. So in order to do that, I'm going to have to distribute a 3 up top. And then remember, this gets distributed to every term inside the parentheses. So it's a little busy there. So 3 times 4x is a positive 12x. 3 times y is a positive 3y. And then finally, 3 times 7 is 21. So what's going to happen is I'm going to go ahead and now add the two together to eliminate a variable. So negative 2x plus 12x is 10x. And then now our y's cancel out. And this gives us 21 minus 11 is 10. And then we divide both sides by 10 to get x equals 1. So I'm going to go plug this into the other equation to solve for y. So I'm going to plug it in up top. 4x plus y equals 7. So 4 times x plus y equals 7. 4x plus y equals 7, yes. So again, I'm plugging it into the original equation. And now we said x equals 1. So 4 times 1 is 4, plus y equals 7. Subtract 4 on each side to get y equals 7 minus 4, 3. So my solution here is when x is 1, y is 3. When x is 1, y is 3. All right, so you guys can try the odds. Looking here, if you just add, you'll be able to eliminate right away. You'll be able to eliminate these, and you're going to get a negative x equals negative 2, because negative 16 plus 14 is negative 2. Divide both sides by negative 1, and you get x equals a negative 2 divided by negative 1 is a positive 2. And then you can just plug in x to solve for the corresponding y. So you're going to go 3 times x plus 2y equals 14. And I'm just getting you guys started on this one, and x is 2. And you can go ahead and finish to solve for y. 6 plus 2y equals 14. All right, go ahead and finish that. Number 81, just to talk to you about it, since you have these two as identical terms, you need one to be positive, one to be negative. But for me, I would distribute a negative 1 up top. That way, you can just rewrite it underneath. So whenever you distribute a negative to each term in the parentheses, they all become the opposite. So this is going to be a negative 2x. This will be a negative 3y. And that's the point of distributing the negative. And 10 times a negative 1 is a negative 10. So now you can zoom in and just add these together. So here you are, 7x minus 2x. 7x minus 2x is 5x. These cancel out, and you're left with 20 minus 10, which is 10. Divide both sides by 5 to get x equals 2. 10 divided by 5 is 2. Now that you know x is 2, you're going to go plug in to either equation and solve for y. The smaller numbers are always easier to work with. So I would go ahead and plug into 2x plus 3y equals 10. So that would be 2 times x plus 3y equals 10. And you're going to substitute for x. X is 2. That's what we just said. And then you guys can take care of it from there. Finally, number 83, just like the previous example, you need to multiply. This is an opposite of a negative 2x would be a positive 2x. So to get this to be a positive 2x, you'd have to multiply by a negative 2, because a negative times a negative will give you a positive 2x. Or you could just distribute a negative 2 to get the opposite of a positive 6y. Which leads me to believe this is a special case, so I'll go ahead and do this one with you. So I'm going to go ahead and, because I have a positive 6y up top, I'm going to go ahead and distribute a negative 2 to get a negative 6y down here. So I'm going to distribute a negative 2. So we get, I'm going to go ahead and just rewrite this over here. The first one stays the same. Negative 2x plus 6y equals 8. Now I get a negative times a negative is a positive 2x. A negative times a positive 3y is a negative 6y. And then a negative 2 times 4 is a negative 8. So when I go to add these, I see something peculiar happening here. Well, when I add them, I notice that these cancel out, so there's 0 things over here, and 8 minus 8 is 0. So what happens is I lost my variable, but 0 is equal to 0, and it's true. When that happens, if it's true, there's infinitely many solutions. However, if it was false, then it would just be no solution if you lose your variable and then are left with a false statement. All right, so let's take a look at this next part where we're using substitution to find the x-coordinate of the solution to each system. Okay, so substitution is beneficial when you have a variable that is solved for, such as y here. What's going to happen is I'm going to go and since y is solved for, y is the expression negative 2x plus 4. I'm going to take the expression of y and plug it into wherever I see a y in the second equation. So with that said, I'm going to rewrite it here. It's going to be a negative x minus 4 times the quantity of y, which equals 5. So I'm plugging it in here and rewriting everything. Okay, so I took the expression of y and plug it in here. So y is a negative 2x plus 4. So now I'm going to distribute. I get negative x. A negative 4 times a negative 2x is a positive 8x. And then a negative 4 times a positive 4 is a negative 16, which equals 5. Now I'm going to go ahead and combine like terms to give you 7x minus 16 equals 5. Now I'm going to go ahead and add 16 to both sides to eliminate here. So add 16, add 16. What I do to one side, I do to the other. So what I'm left with is, go up top, 7x, 5 plus 16 is 21. Oops, so 7x is left on the left side, equals 5 plus 16, which is 21. Now I'm going to divide both sides by 7, and to get x equals 3. Now I'm going to go plug in 3 into the top equation since it's already looking to solve for y. So I'm going to go y equals negative 2x plus 4. Negative 2x plus 4. Well, we just said x is 3, so I'm going to plug in a 3. So you get y equals a negative 2 times 3 is a negative 6 plus 4. And now y equals negative 6 plus 4 is a negative 2. So my solution for this ordered pair, for this system, is 3, negative 2. All right, so that's 84. Let me see how I'm doing on time here. All right, so I'm just going to walk you through because I can't make these videos too lengthy, otherwise they will never upload. So with that, I am going to go ahead and I see that the variable y is solved for, so I'm going to take that and point to the other y in the equation, and I'm just going to set you up. So what you should have here is, I'm plugging in for y, so into the second equation. So I'm going to get 4x plus 2 times the quantity of y, which equals 12. I'm plugging in here into this bottom equation. So now I know that y is 3x minus 4. Okay, so 3x minus 4 gets plugged into wherever I see a y. So it's 2 times y. Now we distribute. So you get 4x plus 2 times 3x is 6x. And you got to distribute. 2 times a negative 4 is a negative 8, which equals 12. And now I'm going to go ahead and combine like terms to get 10x. Oops, let me erase that. Whoops, don't want to do all that. So 4x plus 6x gives me 10x minus 8, which equals 12. So 4x plus 6x is 10x minus 8 equals 12. So now I'm going to go ahead and rewrite this up here. Actually, I'm going to add 8 at this point. I'm going to add 8 to both sides to get rid of the negative 8. So I get 10x equals 20. Now divide both sides by 10 to get x equals 2. So now that I know x equals 2, I can go plug in right here to solve for y. So I'm going to go 3x minus 4. Okay, so x is 2. So y equals 3 times 2, which is 6 minus 4. Y equals 2. So my solution is 2, 2. All right, so to get you started on these last ones, I'm going to set you guys up, and then you guys can use whichever method makes your heart happy. All right, so Eduardo's school is selling tickets to a play. On the first day of ticket sales, the school sold 6 adult tickets and 8 children tickets for a total of $132. The school took in $72 on the second day by selling 6 adult tickets and 3 children tickets. What is the price of each of 1 adult ticket and 1 child ticket? So I noticed that they gave me a total of $132 on the first day, and then on the second day, they took in a total of $72. So the way I'm going to set these up is I'm going to say on day 1, Eduardo's school, okay, on the first day of tickets sales, they sold 6 adult tickets. So they sold 6 adult tickets plus 8 child tickets for a total of $132. On day 2, they brought in a total of $72, selling 6 adult tickets and 3 children tickets. All right, so this is my system of my systems of equations, and let me just make sure 6 adult tickets, yes, and then again, so they both sold 6 adult tickets. So what I would do is, in solving this, I would use elimination by distributing a -1 to either of the equations and solve via elimination and eliminate the adult tickets to solve for the children tickets. All right, number 89. And remember, whenever you distribute a negative, it just changes the signs to the opposite. So say I'm going to distribute the negative to the bottom. So this top one would stay the same. So it would be 6a plus 8c equals 132. Now I'm going to distribute a negative to the bottom, which will change the signs to the opposite. This becomes a -6a, a -3c, and a -72. Now you guys should be good to go, and all you have to do is add to eliminate a variable. Notice these now cancel out. 8 minus 3 is 5c, which equals, what do we have here, 132 minus 72, which leaves you with 60. Now divide both sides by 5, and you get c equals 12. Now all you have to do is go plug it back in to either equation to solve for the adult tickets. So for example, the cost of adult tickets. So children tickets cost $12, while adult tickets cost, you have to plug it in for C, I would into either one to solve for the corresponding A. So don't forget to go find how much the adult tickets are. All right, and this last one, Dad and Jennifer each improved their yards by planting hostas and ivy. They bought their supplies from the same store. Dan spent $52 on 4 hosts and 4 pots of ivy, while Jennifer spent $74 on 6 hosts and 4 pots of ivy. What is the cost of 1 hosta and the cost of 1 ivy pot? So again, the way I would set it up, much like the previous one, is talk about what Dan spent and then what Jen spent. So Dan, they bought their places at the same store. Dan spent $52. Okay, so Dan spent $52. for 4H and 4P. We're going to say 4H plus 4P and spent 52. Meanwhile, Jennifer spent 74 on 6H plus 4P and spent, what did we say, $74? Okay, so there you go. And again, this time I would distribute a negative as well to the bottom, keep this one the same, and then distribute a negative 1 to the bottom. So it'd be negative 6H minus 4P equals a negative 74. Then you'll eliminate the P's to solve for H. All right, so go ahead and get some practice on that one. And this will conclude video number 6. So this is going to be fall final exam video 6, covering numbers 76 through 89.